This is the solar hot water system for my summer cottage, and solar energy from this mirror heats up 75 liters of water that are here. For example, now the solar energy has heated those 75 liters of water to a temperature of 82 degrees Celsius, and the water will almost not lose its temperature until the morning, because it is surrounded by this thick thermal insulation. We can see that I also installed a cheap black film, which is the bottom and walls for those 75 liters of water. Then I put a cheap transparent film on the surface of the water. After that, I installed a sheet of cellular polycarbonate. Then I added a glass sheet. So, we could understand that those 75 liters of water receive solar energy both directly from the sun and from the mirror. And this is the edge of the spot of solar radiation from the mirror. It is obvious that installing the mirror in the middle of land is not the only possible solution, and for example, we can fix the mirror to a wall or to our fence. These mirrors are stainless steel sheets, which were bought by me at $12 per square meter. But I could use such concave mirrors from stripes of ordinary glass mirrors, or such concave mirrors based on cheap reflective film. Let's look at how solar energy will heat those 75 liters of water during one day when they had this temperature in the morning, 57 degrees Celsius. After that, the sky was clear, but it started to deteriorate after 1 o'clock, and this is how it looked after 3 o'clock in the afternoon. As a result, those 75 liters of water reached this maximum temperature of 82 degrees Celsius in the evening. After that, the water temperature began to decrease due to heat leaks through this transparent covering and the thermal insulation. Therefore, now we will see that the coming evening and night will reduce the water temperature by 25 degrees. But this value of loss depends on the temperature difference between the water and the ambient air, and the loss could be only 10 or 15 degrees if the water temperature in the evening was 50 or 60 degrees Celsius. But it is obvious that the water will additionally lose its temperature due to the fact that we take its heat for our hot water supply through this corrugated pipe. Detailed descriptions of how a similar pipe takes heat from water were in this video of my YouTube channel. I remind you that this inlet is connected to the cold water pipe of my summer cottage. Those 75 liters heat the cold water when it goes through the corrugated pipe, and then hot water moves through this outlet to this wash basin mixer and to this shower. But it would be better if that outlet of the corrugated pipe is connected to the inlet of a tank electric water heater or similar tankless electric heaters. I use stainless steel flexible pipe with a length of 9 meters and a diameter of 15 millimeters. We see that I coated it with black paint, and therefore I was afraid that placing the pipe inside the hot water can quickly destroy the paint. Therefore now we will take a look at my pipe after 3 months of its operation inside the water. We can see that the paint is in good condition, also it is only one layer of spray paint without any primer. It is important to remember that ordinary water can form such white coating on our black and transparent films, and we understand that a similar white coating will reduce the efficiency of our solar heater. That is why here I used rainwater, and now we will take a look at my black film after 3 months of its operation under rainwater. Thus, we do not see any white coating on the surface of my black film, and my transparent film also had no white coating after 3 months of its operation. Let's look at how the spot of solar radiation from my mirror moves during one day, from morning to evening. It is morning, and the spot is here, and these are time points during one day of the 20th of August. We can notice that the spot is trying to hit this line from morning to evening. The main condition for this heat is the location of the solar heater and mirrors along this west-east line, with a margin of error less than 10 or 20 degrees. Now we can see the spot better on the surface of the white plates. This is an experiment that is similar to the previous one, but for another day, the 15th of November. So, this is the situation 2 months after the equinox and 1 month before the winter solstice. I remind you that the previous experiment was 1 month before the equinox and 2 months after the summer solstice. Solstices and equinoxes are turning points when the phases of the spot movement change slightly. If our mirror is motionless and fixed, the solar heater should be here at the end of September. Now we can see the comparison of positions between July and September if the angle of inclination of the mirror does not change. We must understand that the height of the Sun above the horizon is gradually decreasing after the 21st of June, and therefore the spot is shifting southward at a rate of several centimeters per day. That is why we need to move the solar heater slightly southward, about once a week. Nevertheless, I solve this problem by another method, which requires changing the vertical angle of the inclination of the mirror about once a week. I do this by means of the simple and cheap device, which I have often shown in my old videos. Now we see a change in positions from July to the end of September, and I remind you that the solar heater was motionless, but the vertical angle of the mirror was changing. However, these were positions for 50 degrees north latitude, where I live in Ukraine. It is obvious that the recommended positions for other geographic latitudes will be different. If this is the direction of the sun's rays at noon in June, I recommend choosing the inclination of the mirror so that this angle is about 30 or 50 degrees. Of course, I chose very cheap but short-lived materials for my solar heater. That is why I am planning to make another video where we will see the lifespan of my cheap materials and other disadvantages of my solar heater.